Welcome back to Python programming from beginner to programmer. We're in the middle of learning how to use SQLite database to be able to store and retrieve data. And we were in the middle of discussing about cross-referencing tables using joins. Let's move over to SQLite Studio and please run that along with me. And we have learned in the previous video segment that cross join, there are two kinds of joins, cross join and inner join. Cross join works a bit like a union that produces virtually all rows cross product linked with all other rows in the other table. And inner join is like an intersection. All the rows are joined or linked to all other rows where certain columns values match. So we talked about that, and now we're going to do this in SQLite Studio. Now, ABC is an example database that we created early on for experimenting. And what I want to do is that I've early on prepared a basic database, and we can link it into SQLite Studio by using database, add a database. So here I'm going to also illustrate to you how to link to an existing database that your current SQLite Studio doesn't see. So that database could have been generated by your friend, your colleague, your groupmate, or by your Python application or by some other applications. So you downloaded it somewhere and you want to look at it, right? So the way to look at it is to add a database. So what we do is we will click on browsing, and it luckily brings me to the correct subdirectory. So ABC was our previous database. We select basic. Okay. Then we say test connection should be okay. It's able to open and close. That means it's able to access that file, that database. So upon clicking, we see this basic here. Okay, and we're just going to double click on it. There are two tables that I've earlier created. One is customer and the other one is transact. They basically contain data that you have seen in the slides. So this is the customer. We can insert by editing in the data tab. Insert these. You don't really have to type in insert. Remember, you can use the user interface to do all these data editing and schema creation. So same thing, we create another table using the user interface, transact, and then enter all these data. So that's all to it. Then we come back to our basic database here, right? So the customer table has got these primary key and so on, just text, integer and text, having the data here. And the transact table has got, again, just very, very basic schema using integer and real because the amount is floating point and text. And then the data is just a screen paste of the information in the slide. Now we would like to perform a select, just a a quick select using cross join. Okay, so the cross join is done by so you get to see your customer and transact or from the slides, so I won't show you that table because I have limited real estate on the windows here. Okay, so what I want to do is to select all the columns from customer, cross join with transact. Yeah, okay, so I can do this. And when I run this, I get the entire listing. So we can forget about the status. And then I get the entire listing of everything. Okay, so you can see there are 24 rows, 3 times 8. There are 3 rows in customer, 8 rows in transact. All combinations. So remember, SQL looks at the entire row as one unique entry. So every unique row is combined with all other unique rows in the other table. Yeah, customer, transact. And another way to perform cross joining is that when you quietly or kind of unknowingly put a comma, you also actually produce a virtual transact table, cross join table like this. Okay, so you end up also getting 24 rows. Why? Because a comma simply means I want to select all the columns from customer and transact, kind of, physically paste them together like that. But pasting them together like that makes no sense because for SQL relational database, the storage internally need not be a table. It can be like all over the place. Unlikely, but logically it can be all over the place. We as user of the database have no say on the internal storage arrangement. So conceptually, we cannot think of um, the customer table as being ordered in any way unless we issue the order by select command. Okay, so just as a variety or another way, in case you haven't noticed, the comma is also a cross join. But of course, spelling it out ensures that we are basically very visibly telling the reader of our SQL code that we are cross joining. Yeah. Okay, good. So now let's try to do this. We go back to our cross join, and then we insert a where customer dot ID equals to transact dot, and you see the drop down here. You can actually select customer ID. Yep. So what does this produce? It produces a subset of customer ID equals to transact ID. Like this is selected. Um, let's see. This is not selected because customer to bill is not didn't spend this amount where the customer ID was 1. So let's run this. We'll get a subset of the 24 rows. Definitely a subset. Okay, so from the 24 total combinations. So this is the relevant subset which makes sense to our business. Then from there on, we would like to further restrict this. But before we go on, let's see how we can also achieve the same using inner. Okay, in the inner join, we would need to change the where to on, right? So this on ensures that we are really trying to merge by value of the relevant columns, customer ID, transact dot customer ID. So when we run this, we'll get back the same 8 rows, but need not be ordered in the same way. So in order to do to ensure, because of efficiency, the SQL Server has the right, I would say. Okay, so it has the freedom to grab whatever row that is matching to what you want, but not necessarily in the order because you didn't say order by. So if you say order by, then after grabbing it, we can then or SQL Server will then have to order and sort it by which column. So you can say by transact.amount. Notice transact.amount didn't participate in any of the previous filtering. In fact, it doesn't matter. It's all independent. Right? It may have been used before, it may not have been used before. But we want descending, we don't want minimum. So the natural order by is ascending, and we want descending. And if we do that, then what we have is the same 8 rows, now descending, descending by the transaction amount. So 12885 and going downwards. Yeah. But we don't want them all. We only want the first row. Okay. So what we can do then is to limit the display by 1. So if we do that, then this will be the case. What if we want, or your boss wants, the name of the second highest spending customer? Second, second. So we just say offset by 1. That would return the second. All right. And then the third, well, offset by 2 and so on. So we can definitely have a lot of control over the amount of data that's being sent back. If the amount of data is residing in a busy server, we can actually use this method to restrict the amount of information that's being sent back so that it doesn't take up long time to be transmitted over the network. But remember, this is SQLite, so everything is just local to the hard disk. This efficiency basically is appreciated, but oftentimes it doesn't matter much practically. Okay, So we are down to here, and certainly, oops, we should remove this and come back to this. So this is our highest amount. And we can always um, list only the information that we want, all right, and not retrieve everything, which may not make sense. And we may want to include how much uh, um, was actually being spent. So when we run this, a few things happen. Huh? So notice that, of course, because of our actual listing of the column names, only the required column names are returned. Number two, the amount here wasn't qualified. Qualified, as in, do you mean customer dot amount? Whereupon SQL will say error because there's no such column in customer table. Or do you mean transact dot amount, which is correct? So here we show you how we can use transact dot amount explicitly. So that's a qualified name, totally unambiguous. It's like you're specifying the file using the full path name, C:\temp/ whatnot, all the way to the file name. Whereas here, this amount is more like just the file name, right? But which directory, right? Isn't it? So this is because what we don't get error because this amount is unique across all the column names between the relevant tables specified in customer and transact. Yeah. So in other words, we could have gotten by with this as well. So you can use the fully qualified name of the column, or if it is unique and you know it by just browsing, then you can just use this. I would say if you have or you are operating on multiple tables, it's good idea to make sure that you are able to use the column names flexibly. So your select queries should, if possible, stick to fully qualified uh, names, column names like this. Yeah? So once we get this part, we have the customer name, address to mail to, and the total amount, and then we can use this amount to decide how many tickets, free tickets, or how many stars to give, or how many credit points to give, etc., etc. So lots of applications, lots of use of this uh, select statement. So when we can select, perform complicated queries using select to read back the data in a way that is sort of timely, contextually sensitive, because we're answering this question, the highest spender or the lowest spender, right? Contextually sensitive and yet not so straightforward, right? So how do we do it? And at the same time, our data is arranged in an efficient way, but not directly apparent when we need to query such business queries. Then what do we do? Just run select in this manner using cross join. And where appropriate, try to use inner join where it applies. Like in this case, definitely applies. And I've highlighted that such situations where you link the customer's particulars to the transactions or the deposit amounts for a bank application case. Um, and e-commerce case will be transactions, right? A lot of cases you will have transactions, events, attendance, right? So all these are linked back to static data, and you have ample opportunities to use this. So when such situations occur, we prefer to use inner join than cross join. But do keep in mind, as you have learned by now, cross join is always able to uh, provide the answer because the answer lies somewhere in the cross products of all the rows in the tables. All right, see you in the next section.